Welcome back to Lab, AP Chem students. Today we are going to be starting the first part of our Titration Fascination lab. So the next couple of labs we are going to be doing are going to be going through the three different parts of titration. We're going to start today with standardization. So in your pre-lab, you should have done the calculations to figure out how many grams of NaOH, sodium hydroxide, you need to measure out to make it 250 milliliter solution that is 0.10 molar in strength. And so we will be working that today and testing to see what the actual concentration is. It really 0.10 or is it a little bit off of that by doing a standardization? So we'll be testing, making this solution, testing it, and titrating it with an acid called KHP to determine its actual concentration. And then we will use that solution in our titration in part B. So I have measured out the NaOH. It is on the scale. Notice the scale is fluctuating a little bit. I'll let you decide on what you're going to do with that mass. And then I'm going to be transferring that mass of NaOH into, there it is, the volumetric flask, 250 milliliters. Notice I have put water in the bottom already. This is a good technique in lab when you're making a solution to add some water, so when the solid drops in, it can begin to dissolve right away. And then, let me back up a little bit. Do you guys see the etched line in the glass right here? That is where we will be adding water up to make 250 milliliters. So I'm gonna transfer it in, and then I'll show you how we're going to mix it up together. All right, I've just added the sodium hydroxide in. You can see some of it is sitting at the bottom of the flask. I've added some water, but all I'm going to do is, for my squirt bottle here in the back, I'm just going to continue adding water until my water line is up to that line in the volumetric flask, and that's when I'll stop. I want the bottom of the meniscus right on that etched line. As I go through to make sure all of that solid sodium hydroxide dissolves, I'm going to stop intermittently and swish around the flask, make sure it all dissociates and breaks up into its ions. And then when we come back together, I'll show you the end product of the solution. Okay. And here's the final look at the solution. Get a close-up so you guys can take a look. The meniscus is right at the bottom of the etched line. I've got no more solid sitting at the bottom. It's all been mixed in. So we should have a pretty good homogeneous sodium hydroxide solution, which we are now going to titrate to see what the concentration is, if it really is 0.10 molar, or if when I was adding the sodium hydroxide, I don't think I did, but some of the sodium hydroxide didn't get in, that would make that concentration a little bit less, or if my line was a little bit above the meniscus line was above the line in the flask, I could also be a little bit more diluted. So we want to get the exact concentration on this solution, and that's what we're going to use the KHP for in our next step. So the next part of the lab, I am going to take the KHP. It's a nice white crystalline. This has been sitting in the class oven. I just took it out and measured that amount. And I'm going to be adding it to sample 1. I marked the Erlenmeyer flask a number 1. That represents this sample. I'm going to be putting that KHP down into the flask. I want to make sure I get it all in there. And one of the techniques I'm going to do is take my water bottle and I'm going to spritz the inside of this to make sure all that KHP gets transferred down into the flask. And then when you come back, I'll have sample 2 weighed out so you can collect that data. Again, I've measured out the KHP for sample 2 because we're going to run 2 trials. Here's the mass we have. And to show that this is sample 2, I have a 2 on my Erlenmeyer flask. Same thing, I'm going to take this and transfer it over. Get it in there. And then again, to make sure I get all that in, I'm going to rinse with some distilled water. And then we'll have our 2 KHP solutions, acidic solutions, set up. When we come back, I'll show you what we're going to do with that. All right, we're just about set to titrate. What you notice is inside the flask of sample 1, I put a magnetic stir bar. What this does is if I turn on the power, it will oscillate the magnet and automatically mix for me. So last time you probably titrated in chem, you had to swirl the flask by hand. Here we have a device that will mix for us. And to this flask, we're gonna add about 100 milliliters of distilled water. It does not have to be spot on. It's just to add more water and make sure all that KHP dissolves and becomes solution in there. So I have a nice acidic solution. So I always like to check before I titrate to make sure there's no solid KHP floating around in there. Looking pretty good. Okay. The other thing I'm going to add to this now, I'm going to jump a step here, is an indicator. And in this lab, we're going to be using phenolphthalein. What phenolphthalein does is, in the presence of an acidic solution like we have here, let me go ahead and add a couple of those drops. You notice there's not any color change. But in the presence of a basic solution, like what we created earlier in our volumetric flask, if the phenolphthalein comes in contact with a base, it'll turn a bright pink fuchsia color. And when I titrate today, as I'm adding the base through this column called a burette, it'll drip out the bottom into my flask. When I start to see the lightest of pink kind of pervade, then I know that I've reached the point where the moles of acid that I have dissolved in here should be equal to the moles of base that I've added from the burette. And that's when I stop titrating, and that's what we call the end point. Last thing we need to do to set up for our titration is to get the base that we want to figure out the concentration for into the burette. I want to get hopefully it doesn't go crazy on me, but notice the burette has numbers and increments on it that we're going to use to measure the volume of base inside that burette. There's also a little valve at the bottom. Right now it's turned off, but if I were to turn it this way, that would allow the base to travel through and out the bottom. And that's how I'm going to be adding my base to my acidic KHP solution that's mixing on the flask. So I'm making sure my valve is closed. I'm going to take that solution and I'm going to add it. I have a little funnel up here that makes things a lot easier. I'm going to add that into my burette and let it fill up from bottom to the top. And to make sure we have an exact volume when I go to record it, I want that base to actually go, I'm going to drip some through so it comes out the bottom, so it fills all of this space up with base also. So to do that, I got a little beaker underneath. I'm just going to open up the valve. I'm getting rid of the air bubble that's basically in here. Okay. You could also do a little jiggity jag where you kind of open it up and you do a little like shake, jiggity jag into the sink, and that'll get rid of the air bubble that is in the tip of our burette. Okay. Anything that's come out into this beaker, we can just add back up into the burette at the top because it hasn't reacted and it was a clean beaker. Cool. So I'm going to have this as my starting point. I'm going to put my hand behind the burette, and then if you guys could read the initial volume, this will be the starting point for our burette. Okay. Now with the base in the burette and we have the initial reading, we can actually start our titration. So you'll notice how I've set this up. The burette, I actually lowered down into the flask. That way as it mixes, the drops that come out won't accidentally splash down the side and we miss volume data that way. The stir bar is in full motion, and you notice I put a piece of white paper towel in between the flask and the stir plate underneath. This is to allow us to see that pink color a little bit easier with our eyes. So I'm going to open up the valve and start adding the base. And we're going to watch for that pink color to persist throughout the whole solution. And when that pink color makes itself persist, we know that the moles of acid are equal to the moles of base I've just added from the solution stoichiometrically, okay, from the reaction. Notice some of the pink that's coming up right now. If I stop that and let it mix, notice the pink fades away. So we're not there yet. That just happens to be some of the indicator hitting the base as it's falling in. Okay. Ooh, getting pink. Should I stop? I'll stop for a second. Okay, keep adding. Getting close. Notice how the pink, when I stop adding, sticks around a little bit longer each time. So I can actually go to a point where I'm adding drip by drip. Seems to be still disappearing. It's persisting a little bit longer now, so I must be getting close. Let me just adjust it so we can go drip by drip. Very, very close now. It is hanging on. It's just not, the pink is not persisting throughout the whole solution. So I'm going to keep dripping. I'm going to stop there. Keep dripping. Just have to have patience with this. The first titration always takes the longest. And then once you have the ballpark, the second titration goes much, much quicker. Or the third, or the fourth if you have to. I just want the lightest cotton candy pink that I can get from this titration. That is not bad, actually. Kind of see it's nice and light, it's persisting. I think we might be there. Okay, so at this point I stop adding my base. I don't want to blast through the end point. I don't want excess base in there because that'll make my calculation off. And we're going to read the new volume on the burette. Let me try to get it so you guys can see. Sorry, down a little bit lower. All right, I'll let you record that. Now we just repeat that whole process over again with our second trial. So I've got the new KHP flask, trial 2, or underneath the burette. I've got the added water to it. I've added the stir bar. KHP looks pretty fully dissolved. There's a little bit of pieces, but I think it'll be okay as we titrate. And I have refilled the burette with more NaOH solution, and our meniscus is near the top here. Let me get in there. Let you guys take that measurement, and that is our initial volume for the burette for trial 2. Okay, now trial 1, we have an idea of how much volume it took to get it to the end point. And so I know I can blast through the first 30 or so milliliters here of the burette and be pretty safe. So that's exactly what I'm going to do. I'm going to speed this process up. And we should start seeing the pink start to develop in a little bit here. If you're blasting through and you don't get pink showing up, it's a good chance you forgot to add the indicator. So in a case like that, you would want to stop immediately and go ahead and grab the indicator and get it into the flask right away. And if it didn't turn bright pink, then you saved your titration. If it turned bright pink, that means you would have to do it over again. Okay. So we see that pink starting to show up now. I'm almost about to the 30 milliliter mark for addition, and then we'll kind of slow it down so we can get perfect at a nice light pink color. persisting a little bit more now. Okay. Keep it going. Remember, we're looking for that pink color to persist all the way through the solution, kind of be homogeneous throughout. It's definitely sticking around right now, but it's not persisting throughout the whole solution. So continue to add some more. Say we're getting close. This would be a wise decision to go drop by drop till we get there. Oh boy, look at that. That is what we don't want to do. That is a very pink titration. This means we've added too much base. Okay, we would want a lighter pink like we had for the first one. So yes, of course I did that on purpose to give you an idea of what to look for, but we'll collect the data anyway. Let's take a look. Try to get eye level with the meniscus so you guys can get a closer look, and boom, you've got your data. All right. Now that you've collected your data for both samples, sample 1 and sample 2, or trial 1, trial 2, you can use your data to go ahead and calculate the molarity for our sodium hydroxide solution. You have a balanced chemical reaction on the bottom of the packet page for part 1. This is the KHP formula. There's the sodium hydroxide solution. And what we formed in that flask was water and then the salt of sodium potassium phthalate ion, the KHP part. So go ahead, go through, figure out your molarity,